Okay, we've done kinetic energy and potential energy. To wrap it up, today we're going to do something called mechanical energy or conservation of energy. So I'm going to give you a quick little lecture on it. You have a reading, and then you'll have the worksheet, which I just handed out to you guys. Now, previously we did potential energy.
Was that yesterday?
No, that was like a week ago. And we studied particularly gravitational potential energy, and we had a formula for it. Potential energy equals weight times height. Or we could also say potential energy equals mass times gravity times height. Remember, mass and gravity is the same thing as weight. So we can break it apart. And that's based on the idea, the higher I hold something up, the more energy is stored in it. And when I let it drop, it's going to have more energy that's going to develop. If I drop this on your head from this high, it's not going to hurt as much as if I drop it from way high. Well, yes, it's a Nerf ball, it's not going to hurt that much. But if it was a bowling ball or something heavy, the higher it is, the more it would hurt. The reason is because as it falls, it converts into what we call kinetic energy. Kinetic meaning moves, like your Xbox Kinect. And we learned the formula for kinetic energy is mass multiplied by the velocity squared divided by 2. Some people will write it that way, some people will write it this way. Mathematically, it's the same thing. And since we're dealing with the velocity squared, that means it's moving. Potential energy, not moving, based on height. Once I let it go, it builds up kinetic energy. And we've done worksheets on this, so this should all be reviewed, hopefully. So, what we have done is we've created a system where something has a certain height to it and is moving at the same time, or can move. And in this system, we call the total energy is what we call mechanical energy. ME. That's mechanical energy, not me. And like kinetic energy and potential energy, it's measured in joules. The capital J, not little j. So today we're going to discuss mechanical energy, or what we call conservation of energy. The formula for it is simply mechanical energy equals kinetic energy plus potential energy. So you're going to have to find both those energies to figure out what the mechanical energy is. That's why we reviewed the formula. Also in your notebook you have that cheat sheet. One side's all the forms of potential energy formula, the other side's the kinetic energy. So refer to your notebook for several of the stuff. What this means is, let's say I have a system. Let's say I have a hill. And this represents height. It doesn't matter how much height. And I can measure kinetic energy, and I can measure potential energy. And for now, we're going to measure it on a scale of 0 to 10 joules. This is just an arbitrary number I pulled out. So what it means, if my mechanical energy is 10 joules, if I add them together, they're always going to be 10 joules.
Pass?
Yes, go get a pass. So if I'm falling down, drop something, and at this point I have a kinetic energy of 2 joules. Based on the height, if I measured my height and calculated my potential energy, over here it would be 8 joules. 2 plus 8 would equal 10 joules. And anywhere along the line, as my ball falls and gets closer, I can build up my speed. As the speed increases, so the kinetic energy, I'd get 8 joules here. At the same height, if I calculated it, I would have 2 joules. 8 plus 2 equals 10 joules. And along the way, somewhere here I would have 5 joules, 5 joules. 5 plus 5 equals 10. And all along, 1 and 9, 9 and 1. It's always going to equal 10. So there's a couple sort of sweet spots which help us figure out stuff. What that means, if my total energy is always going to be 10 joules, that would mean my potential energy at the very peak, just set it right there on the desk, this would equal 10 joules. And my kinetic energy would equal 0 joules. What that means is I'm holding my object as high as it can be. It has the maximum potential energy, but it is not moving. So my potential energy would be 10 joules. My kinetic energy is 0 because it has a velocity of 0. Anything times 0 is 0. In other words, 0 plus 10 would equal my 10 joules. As I let it go, my potential energy, as the height shrinks, so does my potential energy, and eventually it's going to hit the ground and come to a stop. At the ground, my potential energy will be 0 joules, 0 height. However, as it's falling, remember it's accelerating on Earth at 9.8 meters a second squared. It's picking up speed, so it's picking up more kinetic energy. So on ground level, just that instant it hits the ground, my kinetic energy will have its max value of 10. 10 plus 0 equals 10. It's always equal to 10 joules. Here's why this is important. We know how to calculate potential energy. We know how to calculate kinetic energy. What they will often do is they will give you an object. And they will give you a height so I can figure potential energy. But they're going to ask, if I drop this, say, from 10 meters, how much kinetic energy is it going to have when it hits the ground? If you kind of look across, if I know what my maximum potential energy is, I know what my maximum kinetic energy is when it hits the ground, it's also going to be 10 joules. And vice versa, if I know how hard it hits the ground, what the kinetic energy is when it hits the ground, I know what its maximum potential energy is when I lift it up to height. The reason I'm pointing that out is a lot of these questions, they will give you mass and height, so you can calculate potential energy, but they're going to want to know what your kinetic energy is. Or they're going to give you a kinetic energy, they're going to give you velocity and a mass, and you can figure out kinetic energy. But they're going to ask you for a height, which is something you can only calculate in the potential energy formula. So you have to be able to switch them back and forth. The secret is to remember that your kinetic energy and your potential energy will always equal the same number of mechanical energy. Anyone have questions on that? Oh, quick switch here. So, based on what I told you, this should get you going through the quick reading. There is a video on here. So if you're like, Mr. Cook, doesn't make sense again, I'll do the reading and do that and understand it from the video. And then you have your worksheet to turn out. Make sure you do both sides of the worksheet. Notice on the worksheet, on the front side, it says for full credit, you need to show all your math. Make sure you show your math. You don't just write down a number. On the back side, that's not as important. Some of the numbers, once you've calculated something once, you can answer several things without showing the math. It's kind of intuitive. But on the front page, make sure you show all your math to get full credit. On the last assignment, a lot of people miss points because they didn't put the correct units or they didn't show their work. If you just write down a number, I'm only going to give you half credit for it, even if you have the right answer. Questions? Okay, so you have a mechanical energy worksheet to work on today. Hope you had a good time on your field trip this morning. Have fun, folks.